Now, next item. Sometimes, for example, if the group that you're talking about uses the binary operator plus, then quite often instead of using the multiplicative notation, which could create enormous confusion. So if your binary operator is plus, but you're writing it like now, usually you just write that as just xy, right? The multiplicative form. But if your binary operator here is actually plus, then this can be very confusing because you think of it as the product. So in certain circumstances, instead of using the multiplicative convention or notation, and you don't use the circle, you actually use a plus, right? And you do this to avoid confusion if you use the multiplicative. Now, if you do this, then it has certain consequences. Like, for example, if you're going to use the plus notation, what is the unit? Well, the unit then would just be 0. Okay? And what about the inverse? Like, what would the inverse of x be? Well, it's just minus x. Right? Because if the unit is 0, so remember x binary operator inverse is going to be the inverse x, and that has to be e. Well, if we're using the plus notation, you would rewrite this as x plus minus x equals minus x plus x equals naught. Right? There's your unit naught. So that's what this says. For example, if your group, well, set, let's say, is the integers, and the binary operator is plus, then that's a group. You can actually prove that. Now remember how to prove that a set with its binary operator, so S, little circle, that pair, that duo, is a group. You have to prove the 4 properties. So the set, the integers, z, and the binary operator plus, that is actually a group. Now, it might be a nice homework exercise for you to prove that that's actually the case. Alright, now let's do some examples of groups, because there are lots of them. Now think about it. So here are some examples of groups. Q star, so that's your set, that's your S, and the binary operator is times, or multiply. Now, why this star, this asterisk here? Well, if you see this star here, or asterisk, it means that you've kicked out the 0 element, and you do that because it's so much more convenient. If you have the 0 in there, then everything goes haywire. It doesn't work. So often you will talk about sets with the 0 removed. So if you have the asterisk or the star, it's usually just called star because asterisk is 3 syllables, star is just 1 syllable. It's just easier to say. So Q star, okay? And so if the set is Q star, so that means all the rational numbers except 0, and the binary operation is multiply, so that's actually a group. Well, let's actually prove it. So we have to go through the 4 properties and prove it. Okay, so closed. So we have to show it's closed. Associative. C, the unit. And D, the inverses. Okay, so we're now trying to prove that this candidate, this set with this binary operator, is actually a group. So let's do that. Right. Is it closed? Okay, so you take, would perform a binary operation, so any two elements of Q will be of this form, and there's your binary operation. It's okay. Now now B and D cannot be zero, right? That's a condition for a number to be a rational number. You're not allowed to divide by zero. Okay? So B and D are non-zero, and A and C are both non-zero because of the star here. Okay? So that is of the form AC over BD, right? Which is of the form like F over G. That's an integer, that's an integer. So the result is of the form F over G, which is, by definition, a rational number. Okay, so it's closed, right? Because that's true in general. Okay, now associative. Well, numbers, just ordinary numbers, are associative. So here, watch A, C, D, E, F. That will be the same as okay. Now numbers are associative. Just ordinary integers. So I mean that's true in general, right? Because what is this? Well, it's just ACE over BDF, and this is just the same. ACE over BDF. Okay, so it's associative, and that's true in general. So for all possible triples, any three rational numbers you choose, it'll be of this form. So this is very general. So it's associative. What about the unit? Well, the unit, your E, will just be 1 over 1. Makes sense? Okay. Because so then E A will be A E, which is A. Okay. So 1 over 1. A binary operation is times. So this will be of the form x over y, let's say. So that's the same as x over y times 1 over 1, which is just x over y. Right? So the unit is just 1 over 1. So there is a unit that works. Inverses. Now remember here. Here's a general element from your Q star. Now, for an element to be in Q, little n Q star, B is non-zero, right? So that's not 0. But it's star, so A cannot be 0. Okay? So both A and B are non-zero. Well, the inverse of that is obviously just B over A, right? So A times its inverse, so that's B over A. That's the same thing as B over A times A over B, and that's just 1 over 1. Okay, so that's your unit. So for any general member of your Q, its inverse will just be, well, you just flip the numerator and denominator, right? You just flip it around. So for any element A over B, its inverse will just be B over A. Okay, so that's true in general. So all four properties are satisfied, and therefore this set with this operator is a group by definition, because these four properties are satisfied. Now, without going into all these details, I've given you one detailed proof that that particular set and that particular operator, binary operator, is a group. proved it here. It satisfies all four conditions. Now, as homework for yourself, prove that R star, all the real numbers except 0, right? And again, the binary operator is multiplied, times. Prove that that is a group. And similarly, if your set is the non-zero complex numbers, right? C star. And again, the binary operator is multiplied times. Right? Well, let's... I'll do another example. Zn and Zn, where is it? Zn. Well, theorem 13, so here, just following the order on the board. I'll give myself a bit of space. Well, no, I can work here. I have more board now. Now, theorem 13 says the following duo, so Zn plus is a group. Now, if you go back one lecture, can you remember what this is? What this symbol represents? It